Okay, we're going to go ahead and look at graphing some more quadratics. So remember those U-shaped parabolas. And so you're going to need your laptop not only to watch this video, but also to use Desmos here. So we're looking at how the value of C affects the graph of an equation where there is a C value. So for example, if we have the equation that's being graphed like y equals 4x squared plus 7, this is the value of C, that number that's a constant without a variable. So jumping ahead, you're going to want to find this. It's in 8.2, and it says you are going to sketch the graphs of functions in the same coordinate plane. What do you notice? So you have two functions here. F of x equals x squared, and g of x equals x squared plus 2. You are going to go to Desmos, click Start Graphing, and you'll type in both of those functions on the same graph. So you should have two lines when you're done, and then you'll come back and sketch it on your graph and answer the question, what do you notice? What's different? What's the same? So go ahead and push pause and go to Desmos, and when you have graphed them and sketched them and then compared them, you can push play. Okay, so your two graphs should have looked something like this when you sketched it. And then for things that you notice, you're looking about maybe about the width of the graphs. Did one become narrow or wider? Take a look at the y-intercept where it crosses the y-axis. And so a good summary would be that this blue graph, which is g of x, was just shifted up 2 units. So it's the exact same line, but just shifted up units. So my noticing here is that the graph g of x was shifted up 2 units from the f of x graph. So you're really looking at how did that graph change? G of x just moved up 2 units compared to f of x. Okay, go ahead and do the same thing for b. So go back to Desmos, graph these two quadratics, and then take a look and see what you notice. Okay, so you should have f of x and g of x looking something like this on your graph. And then if you notice, they both had an a factor of 2, so the graphs did not become wider or more narrow. But g of x was just shifted down 2 units. So that's an excellent thing to notice. You notice that the graph of g of x was shifted down 2 units from f of x. Okay, next part, exploration 2. You're going to graph each function, and then you're going to find the x-intercepts of the graph. And you need to explain how you found those x-intercepts. So for this, you're going to actually make a table. We're not going to use Desmos for this. And so when you make your table, you can pick whatever values you want. I think -2, -1, 0, 1, 2 should work just fine. So go ahead and make the table and graph for A as well as B. And then you need to find the x-intercepts of each graph. So where the parabola crosses the x-axis, that's what you need to record. So push pause, complete your table, graph your parabola, and look for those x-intercepts. Okay, for A, you should have something that looks like this. I did go and extend my table to include a couple more values here because I wanted to find those x-intercepts, and when I just was at -2 and +2, my graph didn't extend far enough. So now going to find the x-intercept, I know the x-intercept is when the graph crosses the x-axis, so right about here and here. And remember, parabolas are symmetrical, so it should be the same point on the x-axis away from 0 at this point, because I can see my line, my axis of symmetry is right on the y-axis. So if I estimate that this x-intercept is at about -2.7, then I'm also going to say this is at about positive 2.7. But because of the way I sketched my line, it doesn't look like it's exactly where it's supposed to be. And that's just part of graphing things by hand is not always accurate. So my x-intercepts will be at negative 2.70. That's this one right here. My other one would be at positive 2.70. And again, right now all we did is estimate where the graph crossed the x-axis. Okay, for B, you should have something that looks like this. And it's very easy to see the x-intercepts right here. I have one at negative 1, right there. And I have one at positive 1. So my x-intercepts would be negative 1, 0, and positive 1, 0. Okay, a couple follow-up questions. So it says, how does the value of C affect the graph of the equation? So what is this new value of C doing? So if we go take a look here at exploration 1, and you look at the value of C, you had the first equation, the parent function, f of x equals x squared, and then you had the same thing, g of x equals x squared, but it was plus 2. Okay, and we said the graph shifted up 2 units. And for the next one, you had 2x squared, and for g of x, you had 2x squared minus 2. And we said the graph shifted down 2 units. So what that value of C is it's causing the graph to shift up or down a certain amount of units. So you can go ahead and record that. And then if C is positive, the graph will shift up. If C is negative, the graph will shift down. We are going to jump ahead and find these extra practice ones. So you're going to graph the function with a table, and then you're going to compare it to the parent function. And so that is that one where it goes through the origin 0, 0, and it's facing open, it's upwards. And so you want to describe, was it a stretch or a shrink? And was it shifted up or down? Did it open up or down? So go ahead and complete number 1, 2, and there's another 2, as well as 4. And then write a quick comparison to its parent function. When you have all 4 of these done, go ahead and push play. Okay, number 1, your graph should look like this. And then to compare g of x to f of x, we can see that in the equation, this plus 5 caused the graph to shift up 5 units from f of x. Looking at number 2, m of x, should look like this. We can see that this minus 3 caused the graph to shift down 3 units, which is why the y-intercept is down here. Number 2 again. Okay, we can see that the negative caused the graph to reflect over the x-axis, which is why it opens downward like this. It shifted down 2 units, which is the minus 2 part, and it's a vertical stretch by a factor of 3. So this 3 here made it more narrow, and that's what we call a vertical stretch. And number 4, we can see it was shifted down 4 units. I have a minus 4 here, and my y-intercept is at negative 4. And it's a vertical shrink by a factor of a half. So this 1/2 caused the graph to be wider. So it was shrunken down, which makes the graph wider.